My seminar topic is important problem types in designing and analysis of algorithm. So in the field of algorithm design and analysis, it's crucial to recognize and understand common problems types as this can greatly enhance problem solving skills. These key problem types include sorting, searching, string processing, graph problems, combinatorial problems, geometrical problems, and numerical problems. Each type has well-known algorithms that offer efficient solutions, and recognizing these patterns helps in tackling various computational challenges. First of all, we can discuss about sorting. Sorting involves arranging elements in a specific order, typically ascending or descending. It's a fundamental task with many applications such as organizing emails, list or sorting search results. Sorting can be applied to numbers, characters, strings or records, with the most common orders being numerical and lexicographical. There are various types of sorting algorithms such as bubble sort, selection sort, insertion sort, heap sort, radix sort, merge sort, and quick sort. The figure demonstrates the basic concept of sorting. Here we can see two types of sorting, numerical sorting and alphabetical sorting. The figure 1 shows a set of numbers 2, 1, 3, 4, 3 arranged in an unsorted order. An arrow points to a new arrangement where the numbers are sorted in ascending order, that is 1, 2, 3, 4. The figure 1.1 displays a set of letters B, D, A, C in an unsorted order. An arrow points to a new arrangement where the letters are sorted alphabetically, that is A, B, C, D. Next type of problem is searching. So the searching algorithm aims to find specific item within a collection of data. They usually involve comparing the target item with elements in the collection until a match is found or the entire collection is searched. There is mainly two types of searching, linear search and binary search. Now we can look what is linear search. Linear search is a straightforward and simple search algorithm used to find particular element in a list or array. It works by sequentially checking each element of the list until the desired element is found or the list ends. It's the simplest search approach and is easy to implement. When the collection is unsorted and you want to avoid the cost of sorting it before searching, linear search is used. How linear search works? The linear search starts by comparing the target element with the first item in the collection. If it matches, the search is successful and the index is returned. If not, move to the next item and repeat the comparison. Continue this process until you reach the end of the collection. If no match is found, the target element is not in the collection and a not found signal like -1 is returned. We can understand this more by taking an example. The figure illustrates the list of numbers with 37195. Search start by comparing 9 with the first element 3. They do not match. Compare 9 with the second element 7. They also do not match. Compare 9 with the third element 1. We can see it also does not match. Compare 9 with the fourth element 9. They match. So the number 9 is found at index 3. Binary search is different from linear search. Binary search is a search algorithm designed for efficiently finding the position of a target value within a sorted array. It works by repeatedly halving the search interval until the target values is found or the interval becomes empty. The search interval is halved by comparing the target element with the middle value of the search space. Binary search always starts with the entire sorted array. Divide the array in half and examine the middle element. If the matches the target, you have located the target element and its position is the middle index. If the target is less than the middle element, it must be in the first half of the array. So eliminate the second half from your search. Conversely, if the target is greater than the middle element, it must be in the second half. So exclude the first half from your search. Repeat this process of dividing array and comparing the target with the middle element until the target is found or there are no elements left to check. We can understand this more by taking example. Here we can see three figures. So here is a list with the 10 elements. First we set the low and high to 0 and 9 respectively. Then we calculate the mid by adding low plus high by 2. We get 4 as the mid. Comparing the key 23 with the middle element 16, we get that key element is greater than the middle element. So we are avoiding the part which is less than the index of mid. And again we finding the low, high, mid. This continues until we get the key. Here we get the key element at the third step on mid. Next is string processing problem. A string is a sequence of alphanumeric characters which can include special characters. Common tasks include string searching, extracting or replacing a portion of string, and pattern matching. String searching, as we know that it finds a specific substring within a larger string. Extracting or replacing a portion of string involves selecting a part of the strings and either retrieving it or substituting it with another substring. Pattern matching is the process of checking if a string fits a specific pattern defined by a sequence of characters or a regular expression. Combinatorial problem involves a finite set of objects and a set of constraints. The goal to find an object from this set that meets all the constraints and sometimes also optimizes certain objectives. These problems are very common and highly important in practical application. Two key examples of combinatorial problems are traveling salesman and graph coloring problems. A geometric problem generally deals with various shapes and their relationship in geometry, such as points, lines, and polygons. This involves tackling challenges related to constructing basic geometric figures like triangles and circles using simple tools such as unmarked ruler and compass. These problems focus on arrangement and connection between these shapes within a defined space. Numerical problems involve calculations like solving equation or handling numbers and data. To solve this, we use numerical algorithms, which are methods that approximate solutions through basic math operations such as addition, subtraction, multiplication, and division, as well as more complex functions like calculating square roots or logarithms. Common types of numerical problems include organizing numbers in order, finding specific numbers in a data set, calculating the area under a curve with numerical integration, or figuring out solution to multiple equations that are all linked together. These problems and their solutions are essential for handling real-world data and making computational manageable. The last one is graph problems. A graph is a mathematical structure used to model complex systems by breaking them down into simpler, interconnected parts called vertices and edges. Essentially, a graph G can be described as G of VE, where V of G stands for the set of vertices representing the different parts of the system, and E of G denotes the edges, which are the connections between these parts. Graphs mainly come in two types, each suited to different kinds of problems and analysis. This concept helps us to understand and solve real world problems by visualizing their components and the relationship between them. There is mainly two types of graphs, directed graph and undirected graph. A directed graph has edges with a designated direction from one vertex to another, whereas an undirected graph features edges that connect vertices without any direction. Thank you.